All right, so I'm going to take just a couple of minutes today to talk about some of the things that are starting to happen as some of you are sending me emails saying, I submitted this assignment already. Why doesn't it say it's in the grade book? Well, first, let me explain how all of that works. The first piece would be I have prep at 1:30. And so the deadline for the homework is at 1:30 in the afternoon. And if you get your assignment in before 1:30, it is guaranteed to go in the grade book, unless I had to make a comment because something that you did not show enough work. You didn't check your answers, and I noticed that several of them are wrong, and those types of things. So if you're saying to yourself, I know I submitted that assignment, why doesn't she have that in the grade book? The first thing to check would be your little bell in Schoology, the little bell icon that tells you you have notifications, because that's where I would make a Schoology comment. So go back, and you could also look at your assignment, because when you get to your assignment, you're going to see my little comment that pops up there. I'm going to give you, for instance, here, number 34. Oh, come on, blue marker. Number 34. This is what I saw on the paper of some folks. Yeah, obviously, that is not showing your work. That is writing down the answer. And when I see that, my brain says, uh-oh, they just copied the answers off of Schoology. Because remember, I give you all the answers. I can't give you points for that. You haven't earned anything for that. There should at least be a mid-step, possibly 2 on a problem like this, because on number 34, you'd have to multiply them together first and get fourth root of 2,592 x to the 8th y to the 5th. And then you'd have to show me that you knew what to split 2,592 up to, which is, a big thing in and of itself, because you had to go to your fourth power column and find that 1296 went into that twice. And then some of you already know that you can divide these, so let's just say we're doing the smallest steps possible. Some of you already know that 8 divided by 4 is 2, and that 4 will go into 5 once, but with an ugly remainder of 1. So that's a great middle step right there to show me, hey, I know what I'm doing. And then you'd pull it all together and say, well, this is a 6, and I have x squared y, fourth roots of 2y, because those were the ugly ones that I couldn't do anything with. And finally, it was a fourth root, and I do have an odd power answer. Now, if you look at the answer key for this one, the book probably isn't going to have that absolute value there. And that's because the book only does the ones that it says aren't obvious. So the book might consider this an obvious need for absolute value bars, and they might not put that there. And that's one of those things that tells me that somebody's using, this blue marker, if it would just wake up a little faster, that somebody is using the answers instead of doing the problems themselves. Now, if you're saying, you know what, I just should not use the blue anymore either. If you're saying, but Cedarholm, if I just write down this one and then write down this one, doesn't that show that I have it? No, it doesn't. Because here's the deal. I'm not just getting you through this year and trying to get you, the best score possible on any of our tests or any of our homework assignments. My job is to prepare you in case you want to go to college algebra and pre-calculus next year. And so one of the things I wanted to do today was have the pre-calculus teacher talk to you about the importance of showing your work. So hang on a second, I'll grab her. Hi, I'm the pre-calculus teacher. Yeah, I teach both. And in pre-calculus, if you don't show the steps, you don't earn the points. It doesn't matter that you can go from this top line to this bottom line. That's great that you can do that in your head, but you know what you didn't do? You didn't show me how you did it. And if you don't show me, you don't get the points. That's how it works. So some of you that have gotten, probably way too used to the fact that our tests are like multiple choice and fill in the blank and all that kind of stuff, are going to have a real tough time next year in math because you have to show intermediate steps. So, like I said, if you thought, oh, I turned in my assignment in and she doesn't have it in there, go check the comments. It probably says I have to see at least a middle step here. I have to see something that tells me what you're doing. In pre-calculus and college algebra, we speak to our students about how your steps tell a story. This step says, I know that I can multiply these two together. That's what this step says. This step says, Cedarholm, I know how to find that perfect fourth power that divides into 2,592. And this step says, Cedarholm, I know how to simplify, and I know how to put absolute value bars on these problems. So each one of those steps has to speak to me. Don't skip steps. If you do, I can't give you credit for these homework assignments. So double check your Schoology comments every day. I know some of you really like to check campus, so that's good. Check campus every day, and if you're thinking, oh, she didn't put this one in, I wonder why, then go look at the Schoology comments. And if there's nothing there, then email me. Say, okay, Cedarholm, I don't see this one in there. I turned it in before the 1:30 deadline. Why isn't it in? But it could be also you turn it in after the 1:30 deadline. So watch out for those little things. That way you won't have to send emails all the time, wondering what's going on. The comments are already on there, and you can see them. So especially on the last assignment, which I put in, a lot of you got the little comment that 29 to 36 or whatever the last one was. I need to see intermediate steps. If I can't see those, I can't give you the points. So I wanted to start off with today talking about that to make sure that everybody knows where to check. But we are to the point where we just have some extra practice to do here, and then you're going to have lots of work time today. So let's get to these extra examples about multiplying and dividing radicals. But know that I definitely want more of you and less of me for this. This should be stuff where I hear more of the Cedarholm, this is what we should do, because we've been covering this for 2 days now, and I've been doing the bulk of the talking. So I want you to look at this first one, which is the square root of 18x to the 5th y over the square root of 2x. And I want you to give yourself a couple of seconds here to do that analyze piece. And then I need somebody to unmute and tell me what they see.
You can divide the 18 divided by 2 and it gets you 9, which is a perfect square.
Beautiful. So think of it as one big fraction first. And simplify that one big fraction before you go on. So 18 divided by 2 gives us 9. X to the 5th divided by x, or you can think of it as canceling, but dividing similar bases we should subtract. So 5 minus 1 is 4. That'll be x to the 4th. And then of course we have the y. Now it looks like 2 days ago. And like I said, some of you have gotten to the point where you're saying, Cedarholm, I'm just going to do the division. This is a little 2. 4 divided by 2, that's going to give me x squared. But after teaching this for, well over 20 years, this is the way that I can get every student to understand how these radicals work. So away we go. And I would like somebody to give me the pretty part of this answer, please.
So you get a 3 and then x, which is 3x squared.
And then we just have the one piece that's ugly, and that's the square root of y. Unless we need absolute value bars. So it was an even root. Square root is even root. But in my pretty part, I have an even power answer, not an odd. So I don't need absolute value bars. All right. Let me move this one back down so it's a little easier to see. Cube root of 640w cubed z to the 8th over cubed root of 5wz to the fourth. Ooh, that's a monster. All right, analyze. And somebody unmute.
If you put it into 1, you can divide 640 by 5, and you can bring the z down to z4.
Oh, beautiful. Yeah, think of it as that big fraction. Oops. All right, so we need to know 640 divided by 5, and that comes out to 128. And then, yes, the w's. 3 minus 1 is 2, so that'll be w squared. And the z's. 8 minus 4 is 4. So now, I need to know the thinking step for the next part. If you're already trying to do this problem, just unmute and explain. What are you trying to do?
So you want to like make it, you have to simplify it. So for 128, you have to go to the power chart and find a number that like 28 goes into. It has to like also be in like for the cube root and stuff.
Exactly. So cube root 128 would be about here. Obviously 125 isn't going to work. 64. Hey, wait a minute. 64 times 2 is 128. We should use 64. Excellent explaining, by the way. And then again, we've got a cubed root of w squared. Obviously, 3 is not going to go into 2. And then we'd have, oh, I need more space. I was right too big. Now, we can get 3 z's out of there, but we will have a remainder of 1 z. So now I'd like somebody to unmute and give me some pretty stuff, please.
For the 64, you get 4, and then for the cube root of z3, you get z.
Good. Excellent. And the rest of it is ugly. So just make sure you get everything. This was the 4, cube root of 2, cube root of w squared. That was a z. That was the z to the first. And last but not least, does it need absolute value bars? Somebody unmute and let me know about that. Does this one need absolute value bars?
No.
It does not. You're right, because this was cube root, and that's an odd root. It has to be even roots with odd power answers. So those were 2 really good problems. Let's hear from some other folks now. This is cubed root of 3xy squared over cubed root of 2x squared y cubed z. It's a lot of stuff to keep track of. So I need your thoughts. Analyze that, and then unmute and let me know. Here's what I'm hoping is happening in the silence, that you're already starting to do this problem. But the silence scares me. So somebody please unmute and tell me how you started.
Turn to one problem, and then I'll subtract and divide.
Right. Yeah. Even though the numbers aren't going to be anything we can do something with, we see some variables that we can simplify. All right, so we're still going to have the 3 on the top and the 2 on the bottom. No way about that. Now, because we're going to end up with negatives here, there's 2 ways you can think of this. You can say 1 minus 2 would be negative 1. Oh, I'll put that down on the bottom to get rid of the negative. Or you could use canceling instead. You could cancel 1x out of the top and the bottom. Same thing with the y's. 2 minus 3 would be negative 1. That's going to have to go on the bottom. And the z is still down there. So first step was, let's just make this simpler. Let's just go ahead and do the reducing and the canceling. But now we see we still have a denominator. So we need to break it back up. And we have to figure out, what are we going to multiply by to get rid of the radical in the denominator? Please unmute and help me out.
2 multiplied by 2 squared, x cubed, y cubed, and z cubed.
Oh, close, 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 close.
Or no, the letters are squared.
Yes, because we already have 1. That's hard to remember when there's no, exponent there. But we already have 1, so we need 2 more. And whatever we do to the bottom, we have to do to the top. All right, so let's see how our denominator worked out. 2 to the first, 2 squared is 2 to the third. X to the third, y to the third, z to the third. Well, that was just perfect, because now we'll have 2x, y, z. And now we just have to go back and be careful. So follow the order of operations. 2 squared is 4. 4 times 3 is 12. And then we have our little x squared, y squared, z squared. And just like yesterday, you could try looking for a cube root to go into 12, but 8 is the only number we have in that row for third power. In fact, let me put that up here so you can see that. And 8 does not go into 12 nicely. So we are done after we write that numerator one more time. Unless we need absolute value bars, because we have variables in our answer. Does this require absolute value bars?
No.
Yeah, because this is going to be cubed root. Odd roots don't need absolute value bars. So it's not a beautiful answer, but it is, because it's perfect. It's large. We got a lot of stuff going on, but it is perfect. Alrighty, let's write this one down. In fact, I think I'm going to cheat and move this, because I know I did not leave myself enough space, because I do want to write big so everybody can see them. So, cube root of 5xy squared over cube root of 2x squared y to the third z. Alrighty. Take a few seconds. Think about what you would do. And please unmute and let me know.
Turn into one problem and cancel out the x's and y's.
Yes, and by now we should be seeing, hey, most of the time that's our first step. All right, so let's see what happens here. Nothing we can do about the 5 and the 2. That's as simple as it gets. But you could think of canceling an x on the top and the bottom. That would leave you with an x to the first on the bottom. In fact, let me put the 1 there. And then y squareds. You can take a y squared out of both of these, and you'll have a y to the first down here on the bottom. And then we have that z to the first we can't do anything with. So now we've simplified it as much as possible. And our new mission is getting rid of that radical in the denominator. So think about what you'd put down there. In fact, write it down. That'll give me a second to write this down. And then somebody unmute, please, and tell me what we should multiply by.
X squared, y squared, z squared, and 2.
How many twos?
2.
Two twos. Yeah, two twos. Which has me a little worried. Because that's exactly the same thing we had to do up here. It just happened. It's a fluke. You know, two different problems that we had to do exactly the same cubed root on. So now we have the cubed root of 2 to the third, x to the third, y to the third, z to the third, which is, of course, 2x, y, z. And then we just need to go back and carefully figure out what we have in the numerator. Can somebody give me the number part of our cubed root? For the numerator.
5. Oh, wait.
What would we multiply by?
It'd be 20.
Yes. 2 squared is 4. 4 times 5 is 20. And then we have our x squared, y squared, z squared. Again, if we did this right, if we reduced this already, there isn't anything we're going to be doing with the cubed root of 20. And again, the only number we could try is 8, and 8 doesn't go into 20. So never hurts to try. But if you've done stuff right up to that point, you're not going to be able to simplify that numerator. Again, not exactly the most beautiful answer, but it is perfect. It's perfect with what we have. So those were the examples I wanted to make sure I went through with you today to make sure everybody has what they, have it down in your head. Here's what I need to do. And from those I heard from, you are doing a fabulous job. So keep up the good work. 6-2 day 3 is right here. You're going to do a little bit from the book. And then this worksheet doesn't give you enough space. I mean, even if you did print it out, it doesn't give you enough space. Remember, these are always found in the black folder. And it'll be dated. It'll say February 10th on there so that you'll know which one it is that you're supposed to use. And I did this morning have that 16 to 36, all of them. But I thought, you know what, that's a little much. If everybody seems like they're getting this and they're understanding it, then I'll cut it back a little bit. So I changed it to the odds. So 52 to 54, 57 to 62. And then on the worksheet, 17 to 35, the odds, 38 and 39. And again, you don't have to print the worksheet out. You can just pull it up on your Chromebook. If you want to stay here and work on it and ask me questions, that's perfectly fine. If you want to pop off and work on some of the problems and then come back and talk to me if you need some help, that's cool too. But this is definitely work time. So if you do leave and you don't need me anymore, hopefully I'll see you next week, at least those that aren't distance learners and those that aren't sophomores. I am still planning on trying to get you your huge packet of all things copies, all handouts and worksheets and everything. And I will send out an email to the sophomores and the distance learners to let you know, hey, these are ready. You can come pick them up inside door A. But for now, have a fantastic day, everybody, if I don't see you again.
Yep, see you, Cedro.
Yeah, bye. Have a good
I'll
one.
see you on Tuesday.
Yeah, Tuesday. Whew.
Have a good day.
Thank you. You too.